Very often, news or information spread over online social media. So the example that I used to demonstrate this is this Lee family saga that happened last year. I hope you still remember. Um, yeah, so it originated in Mr. Lee's Facebook and then quickly spread over the whole internet. Yeah, but since it originated in Facebook and uh, most of the time the information kind of was shared on Facebook and reposted and so on and so forth. It tells us how news spread over Facebook. Well, the if we want to model this, then the problem is that the external observer does not see the structure of Facebook, right? So we do not know who befriends whom, and we do not know when exactly people share information and how this information passes from one node to another. But what we do have is Google Trends, right? So um, we can assume that it goes like this. So people learn about the event from Facebook, and once they learn about the event, they get interested, and they manifest their interest by doing a Google search, right? So not only they know they are, because they want to know how the story is developing, right? So once they learned, and they learned in Facebook, they go to Google search, type Lee family. In this case, it is Lee family. In your case, it's going to be some other search. Is your choice. But then later, so we can go to Google Trends and download the Google Trend on, say, Lee family from Singapore over a particular time period, and then we can see this graph. Now, what is SIR model? So in SIR model, there are three types. So the time is discrete, so it goes day by day. So we look at who knows the information on day 0, day 1, day 2, day 3, and so on. Right? SIR model is, strictly speaking, the model of spread of a disease. So we compare information to a disease here. Right? So in SIR model, so there are three types of people. Susceptible. So in terms of information, it means that this is a node who does not know about the event yet. So then infected. So infected are those nodes who know about the event, and they manifest their interest. So not only they know, they are interested in it, and they manifest their interest by doing a Google search. So, and this is observable. So we can observe infected, well, we can observe the number of infected nodes. And then there are recovered nodes who they know about the event, but they don't care. So the time is discrete, and the idea is that so nodes who are infected, they can infect other people, right? So then if a node is not infected yet, so then that node becomes infected with probability p. And then if a node is infected, then it is recovered with another probability q. So thus p and q are parameters of the model. So here is what it may look like. So here infected nodes are shown in blue, and the rest are shown with yellow. Recovered nodes are going to be shown in green, but in day 0, when the process starts, so we suppose that some nodes they are infected initially. So these are people who are just own the information initially, and they start spreading it. And so this is what happens on day 0. But then these blue nodes, they have a lot of neighbors. So each neighbor of a blue node becomes infected with probability p. In this case, I think p is 0.2. I don't, well, it's not important. So, but each of these yellow nodes is going to be infected with certain probability. And those yellow nodes that I still say here, so they are not neighbors of any of the blue nodes, they cannot get infected on the next day, right? So then on the next day, some of them are infected. And on the next day, neighbors of these nodes, of infected nodes, they also are infected with probability p. But then notice that sometimes, so now we have some green nodes. So these are former blue nodes that are already not infected, so they recovered. So it means that they know about the event, but they don't care. So then the next day, more nodes are infected, and of course, more nodes are recovered, and so on and so forth. And then you can imagine that eventually, if you look at the number of infected nodes, that initially is going to grow very quickly, and then it's going to decrease because there is no more, everyone has been infected, so there is no more room for more people to get infected. But those who are infected, they will recover. So then, which means that the number of infected people is going to decline, right? So, and then we can plot it. So on the x-axis is the number of iterations, and on the y-axis is the number of infected nodes. And this is what the graph may look like. So in other words, its kind of general trend is similar to this real Google trend that we've seen. And the shape of the graph is determined by these parameters P and Q. So roughly speaking, the bigger P is, the faster it goes up. The bigger Q is, the faster it goes down, right? And then depending on the values of P and Q, this plot may be a better or a worse approximation for a real data downloaded from Google Trends. And what you need to do here is you need to find parameters of the SIR process that fit the real Google Trend best of all.